of this event is to capture the views of a global IT community. The global challenge to the IT profession is that the digital services are now utilities and expected to be available 24/7. In this event, we will briefly set the scene before asking participants for their perspective on this new environment. The focus is on the new different skills needed in this environment, in addition to those relevant to the business and the technical environment that many of us were trained for. We addressed these issues in the roundtable in BCS London. See the link. The event will be recorded and available on YouTube. The Availability Working Group of the IT Leaders Forum will use the inputs as important sources of information to steer their activities. To introduce the event, we have two speakers. Ed Steinmuir, who is Professor Emeritus of Information and Communication Technology Policy at the University of Sussex, and Jill Ringland, who is Emeritus Fellow of SAMI Consulting and a Life Fellow of BCS. Both were co-chairs of the working group. After introductions by Ed Steinmuller and Jill Ringland, we will open up the meetings to questions and comments. These will be limited to 2 minutes per person so over to Ed.
Great, thanks, Paul. So just to set the context, as Paul suggested, services that are based on digital systems are now integral to modern economies and society, and most services delivered by most organizations are based on software that is developed outside of their organization and often outside of their country. One of the fundamental tensions in this area is that organizations vacillate between improving service availability and reliability on the one hand, and developing new services aiming for revenue growth. As Jill will talk later, it's the introducing new services that indeed cause a lot of the problems. So based on this work that we've been doing over the past several years, we've come to some conclusions. The first one is the one I've already talked about, that IT is now a utility, which users expect to be available 7/24. That IT failures have significant impacts on GDP and productivity, with the UK's feeble growth at the moment. It's the difference between growth and recession. The software is inherently fallible. It fails. And I've italicized a couple of the contested or surprising points. The next one is one of those. A cyber attack is not the principal threat to resilience. It's significant, but it's not the principal threat. Software has a long life, and most software is not developed in-house. And the cartoon at the right illustrates the situation that we're in, that all modern digital infrastructure is essentially a house of cards, relying on particular components that have been often in place for a long time, and represented here by the small peg in the lower right, which is captioned, "A project some random person in Nebraska has been thanklessly maintaining since 2003. And the thought balloon is, and she is retiring this year. We concluded that most companies are not addressing resilience issues. This is true definitely of small and medium-sized companies, and indeed it can be true of larger companies as well. And somewhat contested, IT professionals have a limited ability to build in resilience. Also somewhat contested, AI won't fix resilience problems anytime soon. And then the crux of our remarks today, resilience is an organizational, not only an IT department issue. Next slide, please, Paul. So if we want to improve service availability, we face certain barriers. One of them is at the level of the board or senior management, which is likely to take the view it's not likely on my watch, which leads to complacency. A second barrier is that there's no common language in wide use between IT professionals and board and other managers to speak about specific risks and impact on service delivery. And a third barrier is that most services use software, but strategy and management for service delivery is often neglected by senior management. And this is because of factors such as complexity, lack of direct control of system components, and the technical language of software. So thinking about first steps at the level of the organization, the changes that are required are to establish recognition of the evolving role of digital software-based services, that is, their key importance to the organization, to build a common language across the organization to focus purpose and priorities, and to mobilize an all hands, that is, not only the IT department, but other parts of the company that are affected, both inside and also across organizations, to share experience in order to improve service availability. And Jill's going to address these more specifically as to what IT professionals can do to contribute.
So, as Ed says, when we started the working group, we thought that better design was going to be the answer. And it isn't, because software is not only subject to failure, but it's very long lasting. And most organizations don't develop their own software. They do have legacy software around, but they're dependent on third parties. And at the same time, there is tremendous pressure to keep the lights on, to keep the services running. And because this is an end-to-end thing, it's thinking about the effect on users, what users see in terms of their IT supply, their services supply facilitated by IT. IT professionals are starting to have to think about the whole system. And this is different for most IT professionals. So some things sort of spin out of this once you've grasped that it's thinking about the whole system. When you start thinking about the whole system, you have to think about measuring the cost of outages. If this whole system breaks down and there is no service for the users, what is the cost? And there is a framework available that we've written up, which is available for measuring this. And it's about availability expressed in lost user hours. And this is actually so obvious once it's there, but most IT professionals are not aware of the availability and lost user hours of the services they deliver. If you have measurement, then you can start thinking about how to reduce the impact of outages. And financial services are leading here. They've got regulations based on defining important business services. So that's a focus on which services are absolutely essential for the organization's users, and also, of course, for the organization's business model. But it's about the users, and it's about how long the service can be down before there's intolerable harm. And this language of important business services and impact tolerance is something that the working group thought was really important as a language which allowed IT professionals to talk to other managers in the organization and to the board. Yes, of course, an important business service is the lifeblood. It's why the organization's there. Then coming down a level, maybe, IT professionals need to be much more aware of risk, particularly in things like contracts and supply chain management of third parties, because most organizations rely on a lot of third-party software, if not all. And coming back to what might be thought of as old-fashioned tools for business analysis and mapping, because if you're thinking about a system, it's really good idea to have an idea of what it's based on. So that's an umbrella. And then we get into specific methods and tools for achieving resilience. And the first one is forensic failure analysis. And we're starting to do some work with big financial institutions who have just been faced with a major parliamentary committee saying that their resilience is not really acceptable. And a lot of the comment we're getting back is that there's lots of incident capture and analysis in financial services, but there's a lack of forensic failure analysis. And of course, the aircraft industry is a good example of an area where forensic failure analysis works. Another facet that comes out from the data from the 9 banks and their outages is that about 40% of the outages are actually due to trying to introduce upgrades, which puts an emphasis on how do you do testing in a 24/7 operation. And the next up question that's being asked is, surely there were early warnings. How can you use maybe AI to capture the various messages that come out of a complex system and see if there's a pattern that actually anticipates failures? And then a technique that is common, of course, to trying to prevent cyber attacks being effective and other sorts of failure is compartmentalization. So different parts of the system have interfaces where data is tested. And this is something that software engineers used to know about, but has somewhat got lost in the sort of multi-layer type of delivery that we've currently got. And then the last point is, as Ed was emphasizing, digital systems affect and are impacted by silos outside IT. So maybe a role for IT is to build networks across the organization and share the problem and get maybe an insight on ways through. And we did some work with the Business Continuity Institute, who are very much into, why don't we do a simulation exercise? Why don't we use a what if to actually play through who does what in the case of a failure? So the whole approach is, these systems are going to break. There are things we can do to reduce the impact of breakages. There are certainly things we can do to improve the standard of software, but that's not going to affect in the short term. In the short term, it's about deciding what's important to keep the lights on and making that as effective as we can. So we've put the links in the chat because we've written a fair amount about this over the previous 3 years now. And so with that sort of message, perhaps we can go back to Paul, who's going to ask for input. Paul, are you there?
Yes, hello. So the questions for the group are, what do you think are the main causes for the lack of availability, and what approaches, methods and tools can we use to improve this? And whoever would like to go first, go first.
Oh, hi, it's Kevin here. I don't want to, oh, sorry, Arthur, do you want to go?
Go on, Kevin.
Oh, that's very good of you.
Carry on, Kevin.
I think in my humble experience working as a cyber consultant for probably 20 years now, I think it's an interesting point that Ed raises, that not a lot or not every resilience issue is cyber-based. Often it tends to be I need to be careful with my words because I don't want to offend anybody, but it's along the lines of budgetary negligence or budgetary constraints. So basically, if we saw the Heathrow example, utilities utilities as in electric, water, gas, all these other various things, standard old-fashioned type of utilities, are often overlooked or taken for granted. Now, in the case of the substation at Heathrow, the classic case in point, apparently lots of authoritative people in Heathrow were saying, well, actually, we did have alternative power capabilities. They just didn't seem to have that business continuity or service continuity capability written into their practice. So therefore, when the substation that was their primary feed seemed to go offline, all chaos broke loose. And that could well be because of budgetary constraints and understanding how their main feed came, but it also was organizational, run constraints and how they should practice a continuity posture. And quite often, I've seen in comms rooms and things like that where there were uninterrupted power supplies to keep a level of availability going. People didn't take into account the building contractors that cut through a cable, or the fact that the uninterrupted power supplies didn't have their batteries reviewed at various times. So therefore, when there was a planned outage and there was a perception of several hours power still available through the uninterrupted power supply capabilities, those batteries actually was so old they couldn't sustain the capability. And so often I think, yes, there is a cyber threat to resilience, obviously, but quite often it's negligence, malpractice, or fatigue in working patterns, or a lack of enforced process or procedures that tends to actually be the common culprit in these environments. So I just put that out there, really.
Thank you, Kevin.
So maybe I can just put in quickly that, again, coming back to the data, which is very rich from the Parliamentary Committee's publication of outages of 9 banks over 2 years, 3 of them are possibly cyber.
Yeah, exactly.
And there are 148 incidents logged.
And this is just to say very quickly, this is an interesting point, isn't it? Because although we still, in this country and around the world, lack sufficient coverage of cyber professionals to help people in their business, because again of lack of skilled people, because of lack of budget to cover the costs of a full cyber overview, it's interesting that actually, coming back to basic survival of an organization, the primitive aspects here are not cyber related. They're just good continuity practice. For example, you take your car to be serviced regularly. Why? Because most people can't service their car anymore. But the point is, you have a regimen in place that you follow. You actually will take your car to be serviced to enable the continuity of your car. MOTs don't check the health of your car from a sustained product point of view. They check the safetiness, for want of a better point, of your car being on the road. And that's a distinction, isn't it? We don't see sufficient servicing of organizations like you would with, standard sort of assets that we have, cars or other things, gas boilers and stuff like that.
Yeah, sounds good. Arthur, would you like to add something?
Yes, well, there's a couple of points. In terms of systems with single point failures, my engineering discipline, which I was taught many, many years ago, is called failure modes and effects analysis. And the whole point about that exercise is you look at the system as a whole and say, is there anything, if it fails, it will take the lot down. And you always design out that particular cause and make sure there's multiple paths. What concerns me with software and systems is they're not a single product. They're strung together, and there are a number of different products, and you have to hope the interfaces work well. But if they don't, or if they get a piece of bum data like the air traffic control system a few years ago, you can stuff the entire system by just feeding it horrible data.
Yeah. And what do you think we should be learning from that, Arthur?
I have to say better design and better testing. And we have to be very dubious about the components that we bring into systems that we didn't design and we didn't test.
Alice, do you want to make a point?
Yeah, echoing what the others have said, but hi, everybody, I'm Alice Colton-Mark. I'm representing the BCI, but I also do technical resilience on a day in, day out basis. What I found in what works best in practice is that proactive maintenance, that proactive testing. I know in our on-premise data centers, we routinely do test runs of our generators. We flip over to, we switch over to generator power at least once a month to make sure it's all working. We keep the gas tanks filled. Transition that into the cloud where most of our operations are. By the way, I work at LexisNexis for my day job. And then we're doing proactive testing and monitoring in all of our cloud operations. It's important that we constantly be monitoring the systems, have intelligent monitoring so that we can have those thresholds set to say when are things not starting to not run as well as they should, but then proactively test, make things break, test them, make sure that they work in a controlled manner so that we find it as opposed to our customers finding the issues. So it's not doing a plan and maybe doing a tabletop exercise once a year. In technology, you have to test for real. You have to test the recovery of these applications. The other thing I've found that has been a problem is when things are tested in a siloed manner, or a single application is tested, but not everything else that goes around it. My typical practice is I look at it when I'm doing a data center. I look at the data center as a whole goes away. I don't care what took it out. I don't care if it's power failure. I don't care if it's a storm has blown through and the building's gone. I don't care what the cause is. The thing is I've got to get back up and running in my secondary site. I do the whole thing, testing the whole stack, shall we say, then allows you to verify, do you have all your dependencies there? If you can do the whole thing, then you have a much better position to do just components at a time. Same principle is applying in the cloud. I'm taking my business through this and setting up the capability to do this in the cloud services. Again, can you get to all your SaaS providers? Can you connect to everything? Does it all work? Can your recovery site connect to Salesforce or whatever others? That's just a common SaaS provider, but it's important to test it as part of daily operations, not just once or twice a year, but needs to be built into your daily operations. To me, that's nirvana. Are we there yet all the way? No, but if I don't set that as my goal, I won't get there.
Thank you.
Mm-hmm.
Anthony, do you want to make a point?
Yeah, sure. Firstly, can you hear me?
Yes.
Yes.
Perfect, excellent. Well, I was just going to say good afternoon and good morning. I'm actually in Seattle, and so I'm dialing in from sort of the beginning of my day. Just to give you a quick background on me, I was the chief architect at AT&T for 11 years and responsible for resilience and future network architecture. I'm also an ex-Microsoft, Microsoftie, so I'm very familiar with cloud computing. I agree completely with what the last speaker just said. I think you have to continuously test what you're doing, and it has to be tested not just every now and then. It has to be tested when you make changes. It has to be tested periodically. And one of the things we used to do within AT&T, and is still done within AT&T, I'm not there anymore, was we run a full exercise every quarter where we took the network, we effectively broke the network. And that exercise involved a complete disaster recovery teams. We tested all systems every quarter. We were basically federally regulated by the Federal Communication Commission, and we have to basically meet certain standards for both resilience, on security and operational availability, because things like the 911 or 999 emergency response systems are all built on top of that. So testing a system continuously is absolutely critical, and I know many businesses will not be able to do that, but if you want a really resilient infrastructure, you need to do that. The other thing we do, which possibly smaller businesses, medium-sized businesses can do, is you build a service dependency model. So you build a model that basically identifies all of the components in the environment and how they are interconnected. And that's not a manually built service dependency model. That's using tools, because the reality in today's infrastructure is what you built yesterday will be different today, because you're doing something different in the cloud and you're doing something different within the environment. So you build a service dependency model, and you also test that model. You test that model continuously under failure. So you can understand how that's working. One example of someone who actually breaks their system regularly is Netflix. What Netflix do is they have a methodology where they basically, usually once a week, often it's even 2 or 3 times a week, they will pull service. They will just pick a bit of the infrastructure and break it intentionally, because their infrastructure is built on resilience, and they've engineered that in literally from the ground level up. That's something, if you want a really resilient infrastructure, that's obviously something that you need to do. And I agree with the other points which were made about, it's not just software engineering, it's about management practice, it's about operational procedures. Another thing about me, you probably don't, you may or may not know, I'm one of the original authors of ITIL. And we have built into all of the stuff that we do, ITIL best practice, not necessarily as the books say it, but more as, what are some best practices you can do to ensure that you're actually doing things. So, just to summarize, break your systems, break them regularly, make sure you test at least once a quarter, because once a year is too far away. Once a quarter is probably the bare minimum, and be prepared to also be doing continuous tests on effectively a digital twin of your environment, a software dependency model that actually matches it, and make sure that the operational procedures work in your quarterly tests. That would be my advice.
Thank you. Dinesh, would you like to make your point?
Yes, I do. Yeah, so I was basically looking at one of these other things about, CrowdStrike and the debacle, and what we need to do is how we need to plan for something like this. Now, if you remember when CrowdStrike actually happened, which was inevitable, it kind of took, it inflicted about 8.5 million, Windows devices were flawed, and it was basically one of the reason why that happened was a flawed delivery of a channel file in its Falcon sensor update or something like that, which sort of kind of crippled the businesses worldwide. So that was what happened, and basically it took out 30,000 customers, and had lots of blue screens of death all over, and basically with this kind of situation, it's Murphy's law. Basically, it's not been repealed, and what can go wrong will certainly go wrong. So I mean, previously when you had these alternative systems like Morse code and rebuilding a transmitter, there wasn't a single point of failure there. You could have a degradation in communication channels, but it was always going to be up. And then when this kind of situation came, I mean, there was, so why did this happen, and what was the reason for it? I mean, the solution for this is kind of like a canary deployment, where if you remember the canary or the sacrificial bird in the coal mine, in today the canary deployment would basically be releasing a new feature staggered to mitigate risks, or so that you don't break the entire service and avoid complete outage and non-compliance. So yeah, that was the kind of thing that they had to do, but they hadn't. And so the CrowdStrike, basically they started adjusting their deployment strategy and enhancing its testing and processes to include sort of providing customers greater control over the delivery of rapid response content, and that kind of nicely fitted together, and that was a plan that they kind of came up with. And yeah, I just wanted to share that how deployment strategies are quite important, and how they deploy an application or an upgrade and take out the whole system, and losing billions worldwide. So yeah, that's me. Thank you.
Thank you. Jill, did you want to answer something? Or?
Well, I've been sort of looking with interest at the chat, and a theme that's coming up is measuring the risk, measuring the cost to users. And at the roundtable that we had earlier this year, this was one of the key ideas that came out, which is that if you've got a cost of failure, then boards can work out how much to spend on insurance versus how much to spend on extra work inside. But unless there's a cost involved of failures, it's quite hard for boards to actually make that trade-off. And so getting a cost to users of the failure is an important plank in creating a common language, so that the technical people who understand the problem can actually get more backing from the board. So I thought that was an important point to come out. And Kevin has been suggesting a framework, but I wonder whether we need a framework, a new framework. The NIS framework of lost user hours is, it's a good place to start.
Yeah. Steve, do you want to make a point?
Hi, Paul. Yes, how are you doing? I've been listening with interest, and there's some tremendous points coming across from all of the contributors. I think they're all very valid. I've just got some sort of random ideas and thoughts going through my head. I've been working with Jill and Ed on this for some time, as some of you may know. I chair the ISSG, which is primarily concerned with information security. And of course, the three pillars of information security are not just confidentiality and integrity, availability is in there too. But it's interesting because availability is often kind of the poor relation, certainly from an information security or a cyber security team. Many organizations think that that's really the remit of the IT teams. But in essence, one of the problems that I often come across is that availability isn't really defined anywhere. And part of the reason for that, I think, is oftentimes nobody really is made accountable for it until way too late, way after things have started going wrong. So, when you're designing a system, building it, doing the architect piece, there's a whole pile of NFRs, non-functional requirements, and availability is one of them. Certainly in the business that I'm in, which is supplying fraud prevention services to the financial services sector, availability is key. And thereby lies another of the problems, I think, and that is that probably we can't consider all systems to be equal. So talking about IT generally as a utility, I think is a very helpful thing for us to say and to articulate, because it's easy for people to understand. But equally, I think we need to understand that not everything is equal, and that while some systems need availability of 5 nines, others clearly don't. However, someone somewhere ought to state what the availability of a given system should be, and then report on it. The system needs to be designed against that availability requirement, and then somewhere, somehow, we need to report on whether we're meeting that availability targets. So apologies, I've probably rambled just a little bit, but the question of who decides on that availability is probably key in here. Now, if you work in critical national infrastructure, or if you work in financial services, those things are generally set by either a government body or a quasi-government body or something like the FCA or the PRA. In industry general, it's a kind of commercial decision, often left to boards who oftentimes don't really understand the problem until it happens, until something goes wrong. So it's getting that understanding early on in the life cycle of a system and making it a very upfront question, non-functional requirements, availability, what is it for this system? And then you can start to bake in some of those considerations that Jill was talking about, standard risk question. What is the impact, whether that's to the business, commercially, reputationally? Ultimately, that comes down to a pound sign, but also to the users, because ultimately, if the users don't feel as if the system is resilient enough, if it keeps failing, if there's another option for them to go somewhere else and get a similar service, they'll simply do that. They'll walk with their feet, and thereby it ends up back at the commercial for the business. So ultimately, someone needs to define what that availability needs to be for any given system or organization, and then they need to be held accountable for it. And until we can get those two things, then they're kind of the starting point, in my view, for all conversations about availability. Final point again, then, just a reminder, I don't think all systems are equal. I don't think we can or should expect 5 nines for everything or greater. I think it very much depends on the context of the system. I've probably rambled enough. I'm sure I'll come back in later, though, if you'll let me.
Thank you. Arthur, did you want to make a point back on something?
Yes, very much so. If we look at the incidence of system downs, an awful lot of them are caused by failed updates. And CrowdStrike is a classic example where it rippled across the world. It was one failed update, but it took out an awful lot of systems. So my approach would always be to test an update on a spare system before you actually roll it out live to something critical. So that was my point.
Yeah, thank you. Adrian?
I can't speak officially. I'm I've changed job since, but I spent 6 years with as essentially the technical director, subcontracted out to National Air Traffic Services. So in that 6-year period, that also covered COVID, which was quite interesting. And obviously NATS is critical national infrastructure. The Swanwick and Prestwick arrangements basically went into lockdown weeks ahead of the country before that, because keeping the air traffic moving was seen as that critical. And their systems are, their core systems are fully duplicated. To provide fault tolerance is a contractual level for 5 nines for availability, as Steve was saying. Perhaps somebody needs to set barriers. Well, if you're going to be CNI, you can actually contractually serve that, set those sorts of things, and that has side effects. Because I'm a network person, I've taken an enterprise architecture type perspective. Exactly as Jill said, taking an end-to-end desktop to data center. Well, some of the systems, when you've got sensors, air, ground, air, radio sensors and radar systems, the whole thing's around 70 sites that are critical national infrastructure, and it's got to be high availability. So every one of those sites has got to be, to provide a contractual 5 nines, at a best efforts delivery, or reasonable endeavors. However, the two are slightly different. Getting physical diversity is fine for the communications links, but you've also got to have the physical diversity to the power supplies to these sites, and getting power and comms physically diverse up to mountain tops in the Outer Hebrides can be a little bit of a challenge when you're trying to do network modernizations. But that's because of the safety to life type environment and attitude of the parent organisation essentially subcontracting out. There are a number of the availability is a key thing, and I think power supplies. Yeah, on my watch, I don't have any major power supplies failures. There are incidences where NATS have reported things like standby generators going in major storms. There are one or two articles on the NATS website on that, and of course all of the stuff. All of these sites, physical resilience. You've got to be in a position to understand the network, how your information is flowing, particularly. If you've got physical diversity, we had to prove the physical diverse paths, literally fiber hop by fiber hop or microwave radio shots welded to microwave, or beneath this sort of IP type networking level, and be able to demonstrate that sort of diversity to the customer for their safety case to maintain that criticality. I think one of the things there's a lot of process and procedures. When there were incidents, and I didn't have an entirely clean watch in 6 years. There were a couple of incidents where I was on a please explain to the IT operations bridge at Swanwick, but that was like within 48 hours of something happening, and the attitude really was, we want to learn from mistakes. If something's gone wrong, there's always another level behind. So they've done a lot. They do a lot of network, or scenario modeling beforehand. Every operational incident, you learn from it. How can we refine the process and procedures? The high-level process and procedures, are pretty well established and reviewed on a regular basis. And the other point I would make, during COVID, the 5 nines, it sounds a high thing to achieve, but there was a 6-week period where there was basically a ban on anybody going into any machine room type environment. And during that 6-week period, I think we could have claimed 100% availability if it wasn't for a fiber smash, courtesy of builders, and 2 incidences of human error, just misconfiguring boxes. Otherwise, that 5 nines would, it's take the human out of the machine room, away from the command lines. When everything's stable, it's all happy. But I'll leave it at that stage.
I think the key bit you're making there is it's change that generally causes the problem, isn't it?
It has to be very well planned, and in fact, both instances that did happen on my watch were both at where changes occurred and have been pre-planned. And it's, you can, if you fail to plan and you've planned to fail, but sometimes the best laid plans of mice and men can go slightly awry and have an unintended consequence. And it's been awake to that and been able to rapidly react. Certainly my employers at the time, NATS account was rather sensitive, very brand aware, and in terms of brand damage, as an account to have, they were high on the risk register, because if something went wrong with the air traffic control system, my employers at the time certainly did not want to be on the receiving end of finger pointing, or to be found to be the root cause of or in any way associated with any sort of failure. Because the brand damage that could do, if it was company X caused this, or caused the air traffic control to fail, that brand damage incentivized the board, went up to board level in one of the major telecom companies.
Yep. Thank you. So, Kevin, do you want to make another point?
Yeah, just 2 things really. To build slightly on Adrian's point, and then another distinction, but I'll be very brief. So I think it's a very interesting point that Adrian raised about we had raised, and also it was picked up upon relative major change and how that affects wider change. So if we look at the Southeast Asian tsunami, if we look at 911, if we look at COVID, if we look at swine flu before that, major events that I'm going to be apolitical. If we look at changes of various political leaders and how that might impact people's alliances globally, you can begin to see how the force for change is often a significant dynamic event, which shifts as a pivotal thing, an approach. For example, let's take a more sort of nearer to home one that was a significant global event with COVID. Lots of businesses had to shift supply chain very quickly in order to continue capability. Otherwise, they were out of business, or people couldn't be fed, or there'd be riots on the street. So that was quite, and also from a digital point of view, how Teams and Zoom stopped crashing every 2 minutes and then became more stable for people to do business. There was, a widespread level of dynamic and broad change enabled across many supplier bases to keep continuity of service active. Some fantastic lessons to be learned there. What a major event when it came to sustainability, right? So there's lots to be gleaned from that. The other thing, I'm going to be slightly mischievous, and I don't mean to be, but I think it's a key point, is that at least in the UK, our government has shifted to rhetoric rather than saying about, being secure, being aware and stuff like this. It's using that strap line of resilience. Now, of course, the assumption is that resilience is critically about availability. And of course it is, because if something isn't available and has a resilience behind its availability, it causes issues. But I think from a government perspective, resilience has a wider tone. They're talking about secure by design, making sure that security is built from a cyber point of view, is built into the capability. So if, from a confidentiality point of view, you're only allowing people to access what they need to access, you've got secure encryption for any links, etc. And for integrity, that you're stopping the modification of data or information any which way. So I think government is using resilience in a wider term to cover, well, how are you resilient for data confidentiality? How are you resilient for modification of data? But how are you resilient for your service? Now, of course, this topic is primarily around availability, but what I'm trying to shine a light on is, from my point of view, and I think it is correct in saying it from a government point of view, they're using resilience as a much wider, looser term of reference for, for your capability. Can you tell me that it would stand up under pressure in any one of those three main pillars? And I think availability is a critical one, but I think there's a wider aspect to resilience that isn't just about can your service be active. It is about the quality of your other areas, from protecting your data from modification or breach as well, is something that should be considered somewhere along the way.
Thank you. Ed?
In the chat, Ellis raised the issue of when failure occurs, falling forward. And I wanted to invite her to expand upon that a bit, if she would.
Sure. The concept is, instead of failing back to where you are, basically fix the problem and keep going forward. That is what is the general mode for cloud operations, is failing forward more than failing back. So that requires, obviously, a lot of redundancies in storage, a lot of replication of databases, et cetera, and leveraging orchestration tools that your cloud service provider would offer. But it's the concept, instead of going back to a point in time, fix whatever the issue is and go forward. So there's more nuance to it, obviously, but that it's a more way of thinking about how you continue to operate. You basically fix and keep going forward. And that, I know that from a cloud operations standpoint, that's what we typically do quite a bit, mainly because things are moving so fast. Moving back in time actually causes more issues than moving forward in time.
Thank you.
Mm-hmm.
Jill, did you want to make a comment?
A quick comment. There's been a discussion about ISO standards in the chat. And it seems to me that ISO standards work when it's a technical issue, a product issue. But when it's a process issue, and increasingly ISO standards are being issued for processes, they only get half the picture because, and so I went to an event one time where the Chartered Quality Institute was giving prizes to financial services for their quality processes. And the top 3 prizes went to people who had actually been on the front page of the Times in the previous week for fraud by senior managers. And that's because the process was fine, but the implementation had not been monitored and followed through. So I think there's an issue there about ISO standards and where they're absolutely essential and where actually they unless they're implemented, and there's no check on how to implement them. So that was my quick point.
Anthony?
Hi again. Hopefully, I'm not going to monopolise this here. There were a couple of very good points made recent, just on by the fellow sort of people on the call. And there was one thing, obviously there were a couple of things I sort of picked up from that, and that was specifically the point of resilience. And for me, the point of resilience is about people. It's not just about the technology. It's about having the right number of people to actually operate your environment when you don't have a single, and I think it was also brought up regarding air traffic control about no single point of failure either on power or on networking. The same goes for people, and this is where I think a lot of organizations get it wrong, is they have one person who knows a platform and they don't address that, the workload on that person, and then that person retires or leaves or goes somewhere else. And it's important to do succession planning. It's important to have clearly documented roles and for there to be more than one person covering that. And then when you look at sort of defense in depth and resilience, particularly related, let's say, to the military, is you don't have a single person. There's always a line of people behind that first person. So if someone gets unfortunately taken out, there is 2, 3, 4, 5 people behind them who can take that role over as seamlessly as possible. And that's something that I think if you're building resilience into an organization, you have to make sure that you can do that. It doesn't necessarily mean you need lots and lots of extra people. It means that I understand what you do and you understand what I do, and we swap roles regularly so we can actually do each other's roles. The other thing I mentioned when I spoke first time, I was talking about disaster recovery and having an exercise every quarter. Part of that exercise is not just systems. We have a complete, when I was at AT&T, we had a complete operational recovery group where we have equipment and plant and technology based in 4 warehouses across North America. And what we actually do is we run an exercise where we go out and we actually take a piece of critical infrastructure, for example, a central switch center. We take that down and we put in the recovery teams with the recovery equipment, and they take over the operation of that using the recovery equipment. And that includes pretty much every type of disaster. And I know this is probably just maybe taking it one stage too far, but just so you to understand sort of level of training that the people go through. One of the teams are trained in hazmat. And so they are given exercises where they actually are given Lego sets, and they have to basically build Lego models in hazmat suits. So they can actually understand these are engineers that would be maintaining the network or power or others. And how do you actually do that when you're in a hazmat suit? You have to actually be used to operating in that. And I know it may sound like a silly example specifically for a BCS core, but being able to do a recovery exercise and being able to recover whatever your job is when you've got adverse situations around you and also understanding what your role is and how you recover is critical to getting to fast recovery. And we know this. We've had both many successes and a few failures, well publicized failures as well, in our infrastructure. So it's just something that needs, my view, needs to happen. Thank you.
Okay, thank you. Does anybody else want to make any points? Jill, Ed, do you want to wrap up at all?
Sorry,
Anthony got his hand up.
I'm sorry, I lifted it up. My apologies.
Ed, Jill, do you want to make some closing statements as we've
Over to you, Ed.
Great. So thank you all for your participation, not only with the spoken comments, but also in the chat. There's a lot of material in the chat for us to take account of. And as was said earlier, we're going to take all this input into our future work. We're having another one of these international sessions later this week, in which we're going to cater to the time zone of East Asia. So we'll be getting up bright and early to do that. And from that, we will be informing the development of what we're now calling the availability working group, compared to our previous resilience working group, about the skills and techniques necessary to improve availability and resilience. Jill.
So just one final point. Because we use Eventbrite for registration, there are a lot of people on the call that we don't have emails for. We would like to be able to circulate the write-up back to participants. So if you would like a copy of the write-up or to comment on it even, could you put your email in the chat, please, before you disappear? Please.
Thanks all. I think we'll close the meeting now.